Welcome everybody to the openStars video series. This is a series of 6 videos, not including this little introductory video, each of which will be a little bit less than an hour long or so. And taken all together, this package of 6 videos makes up what I'm going to call a semi-popular course on basic stellar astronomy. Now, the unique thing about this course is that we're going to be taking an inquiry-based approach, that as we go, we are going to demonstrate and discover important concepts by doing experiments and demonstrations using the Greystar 3 virtual star simulator, which is what you can see running here in this video. Because the Greystar 3 virtual star simulator is the star of the show here, no pun intended, let me tell you a bit more about it first. Greystar 3 is a free web application that anybody can access. It's hosted in the Astronomy and Physics department here at St. Mary's University, and because it is a web application, it will run in any web browser. And so that means that it will run on any device for which a web browser is available. And that includes things like tablets. It will also work in mobile web browsers, so you can use it on mobile devices as well. Now, if you want to go to this application in order to check it out, you can see the URL here in the URL field in my web browser, or you could find your way to it by Googling Greystar 3. Now, throughout this video series, I'm going to be running Greystar 3 in the Chrome web browser, which is what I'm doing here. I want everyone to have a good experience, so I'm just going to let you know that in my experience, Greystar 3 runs most reliably and responsively in the Chrome and Opera web browsers, although it will work on any web browser. So what Greystar 3 does is it turns your web browser into a virtual star that you can play with and experiment with. So at the top here, we have some input controls that allow the user to adjust the parameters that control what kind of star we'll be simulating. And then down here below, we have a number of outputs that show us what the star we've simulated looks like in various ways. So for example, right here we have a direct image of what the star we've simulated would look like if we could see it close enough so that it's an extended object on the sky where we can see surface details like we can with the sun. And then there are some other observable outputs here as well that I'll tell you about as we go throughout this series. Now, of course, it's the whole purpose of this video series for me to tell you what all these various inputs and outputs are, but I'll just let you know that a way to get into additional information is to click or to hover on something. And that will work with most things here. So for example, if we wanted more information about this, we could simply click on it and a tab would open up, giving us a Wikipedia page with additional information on whatever that thing is. And additionally, for many things here, if we hover, then a tooltip will open up, giving us an extra clue as to what that thing is. Now, I've discovered that tooltips will not work when I'm shooting video of my desktop, but trust me on this, if you check this out for yourself and you hover on something, you'll find a little yellow box opens up, giving you a few extra clues as to what something is. So there is additional information there in addition to what I'll be telling you about throughout this video series. Now finally, I'll also let you know that Greystar 3 is really a simplified version of the more complex stellar simulation codes that are used in astrophysical research. In fact, Greystar 3 was developed here in the Institute for Computational Astrophysics and the Astronomy and Physics department at St. Mary's University. While we're talking about the application itself, let me just show you the main Greystar 3 page and the resources that are there. So if we go up here to the URL, I'm just going to go up one level in the directory structure here, and we'll get taken to the main Greystar 3 page. So there's a number of things here, various supporting resources. There is a blog. Part of the Greystar 3 philosophy is to cultivate sort of a vigorous and freewheeling community of teachers and users and developers who can share ideas and suggestions for lesson plans and lab projects and things based on Greystar 3. So there's that community-oriented stuff going on here. And then if you do think that you want to use Greystar 3 in your teaching or let your students have access to it, then you may not want to rely on a connection to a remote server here at St. Mary's. And you don't have to. One of the things that you can do is download a tarball, a gzipped tar file here that contains the complete suite of files that you would need for your own local installation of Greystar 3. Now, if you're not sure what to do with a tarball, maybe you have an IT professional at your university or at your school who can help you out with this. But be aware that people are encouraged to download and develop their own local installation if they wish. So this is also the page from which people can run Greystar 3. So let me just click on this link here, and that will take us back to where we just were. So I should say a little bit more about who this video series is intended for, what level things will be aimed at, and what people can expect to get out of this. And I really have two audiences in mind here that will have a couple of different goals. So the first audience that I have in mind is anyone who is interested in astronomy, especially in the nature of stars. And if you are someone who wants to hear about this at a level that's, say, one step beyond the level of a popular documentary for a general audience. So maybe you are somebody who has already recently seen a couple of good popular documentaries on astronomy, or maybe you are someone who has recently taken a college or a university course in astronomy for non-science students, and you've decided that you want more. You've decided that you want to take things to the next level. Or maybe you are someone who is thinking of taking a first or a second year college or university course in astronomy, especially stellar astronomy, and you want a preview of what you're going to be getting into so that you can find out if it's really for you or not. Or maybe you are somebody who is currently taking such a course and you feel that you could benefit from some video tutorials to supplement the course that you're taking. Then if you are any of those people, then this video series could be just the thing for you. In this series, we're going to be talking about things and thinking about things a little more the way actual research astronomers and astrophysicists do, more so than they would do in a popular documentary for a general audience. However, in the grand scheme of things, the level here is still going to be fairly basic. And just as a reality check, I would say that a well-motivated and enthusiastic high school student who likes science should have no trouble following the information in this video series. And another thing I'll let you know is that in this video series there will be no math. I'm not going to be showing you any equations. In fact, that's the beauty of using Greystar 3 as the basis for our approach, that I don't need to show you any math. We can demonstrate things in a very convincing way just by doing experiments with Greystar 3, simulating stars and seeing how various things play out. So the final thought I'll add here is to let you know that the focus of this video series is very much on stars. And in the 6th episode, we'll also be talking a little bit about extrasolar planets, but it's mainly about stars. So we're not going to be talking in this series about galaxies or about cosmology or about black holes or any of those other things. We're going to be talking about stars. However, if you are someone who is interested in galaxies and in cosmology, that's good. But I'll let you know that a foundation in the understanding of stars is really important for understanding those other things. We can do cosmology by observing other galaxies beyond the Milky Way, that those other galaxies help us trace the universe for cosmological purposes. But galaxies, of course, are made up of stars. When we look at other galaxies, we are looking at the combined light of all their stars, and it is important to have a solid foundation in stars in order to understand galaxies and to do cosmology. Now, throughout this video series, there are a couple of times when I'm going to be mentioning some pretty important connections to cosmology. The second audience for this video series is college and university instructors and high school teachers who are teaching or who are thinking of teaching a course or a major unit on stellar astronomy and who want to follow an approach in the classroom that is demonstration based, or who want to be able to give students lab-style homework assignments and projects where they can experience stellar astronomy directly. So of course the point here is that Greystar 3 is an application that has been specifically designed to allow instructors to do demonstrations in the classroom and to allow students to put their hands on a virtual star and do lab-style homework projects. So a second purpose that this video series serves is that it serves as a series of training videos for teachers and instructors on how to use Greystar 3 to do demonstrations. So we're going to be showing teachers what can be demonstrated and should be demonstrated with Greystar 3 and how to demonstrate it. So part of the idea here is that each of these videos should provide teachers and instructors with ideas for lesson plans. In fact, each video really models a major lesson plan, and of course those lesson plans can be adapted to suit whatever level you are working at. Now I'll also add that if you have followed developments over the last couple of decades in physics education research, or PER as they call it, for example, if you follow the work of Randall Knight, then you may know that a lot has been established about the pedagogical effectiveness of doing experiments and demonstrations in the classroom. So the idea here is that if you have a classroom PC hooked up to a data projector, or if students have access to classroom computers in the room, then you, after introducing the relevant material, you can set up an experiment with Greystar 3 by setting these various controls to specific input values, and before you hit the model button you can have students discuss the situation and make a prediction, or use clickers to vote among multiple choice predictions if you're using that technology, before hitting the model button and running the experiment. So the other shoe that drops, of course, is that you can give students lab-style homework assignments or even major term projects where they have to use Greystar 3 on their own computers, and they can do so and put their hands on the controls and follow a procedure and generate a lab report exploring some idea. A lab report complete with background theory and discussion questions and conclusions and a data table and all of that. So in fact, in each of these videos, near the end, I'm going to actually suggest one or two pedagogical activities that can be done with Greystar 3 on the basis of the material that we discussed in that video. Now, in the spirit of lesson planning, we're going to be taking things carefully throughout this series, that things are going to be introduced in a staged way. In each video, we're just going to be introducing one or sometimes two closely related stellar properties, and we're going to be introducing one new Greystar 3 input control in each video. So I'm just going to finish up here by giving you a little sneak preview of what we're going to be talking about throughout this series so you can get more of a sense of whether or not this is for you. We're going to spend the first 4 videos talking about the 5 basic parameters or properties that characterize a star and that distinguish one type of star from another one. Then in the 5th video, we're going to put it all together and tie a ribbon around it by talking about something called the HR diagram. This is the most important diagram in stellar astronomy. You can see a sneak preview here where we plot up a large representative sample of stars according to one of its measured properties that we're going to be talking about versus another, and we can learn a lot about the nature of stars by looking at this diagram. So this diagram, the HR diagram, is really the pedagogical capstone of the first 5 videos in this series. And if you are a teacher or an instructor thinking about preparing a unit or a course on stellar astronomy, then having as your end goal getting the students to the point where they can understand and appreciate this diagram is really the jewel in the crown of a good stellar astronomy unit. But to get there, we really do have to spend some time talking about the basic properties that are being plotted up here. So finally, there is a 6th video in which we deal with kind of a bonus topic, namely the circumstellar habitable zone or the life zone around a star. So this is something else that can be simulated with Gray Star 3. What this refers to is the range of distances that a planet would have to have from the center of its host star if conditions on the surface of that planet are to be suited for supporting life similar to that we have here on Earth. But calculating where this circumstellar habitable zone lies depends on some of the basic properties of the central star that we'll be talking about in the first 4 or 5 videos. So this topic really is a natural extension of the first 5 videos. And of course, this is something that is very topical these days. The news media contains reports of increasing numbers of planets being found by astronomers around other stars that are a little bit different from the Sun, the so-called extrasolar planets. So that is a topic that we will look at in the 6th video in this series. So if this sounds like it's interesting to you, then I will see you in episode 1. Thanks for checking it out.